Hi, everyone, and welcome back to the Nick Hilaire Show. Yeah, absolutely. So, when it comes to let's talk for a second about the old way of doing incinerating trash. What is bad about it besides the carbon? I thought the story there was that it's carbon intensive or it produces a lot of carbon and it's costly to do it. And it also releases like nasty toxins in the air.
Well, I think waste incinerators definitely at one time were quite toxic, right? They had
Okay.
they had bad emissions control. I think now the modern waste incinerators are actually they do go through stringent tests. Particularly like in Europe, that's the main way of getting rid of garbage. Incineration is they don't have space for landfills in Europe, right? So in Europe, the incineration technology is actually very advanced, and so they have all these different ways of filtering the air, the emissions that come off from the incineration. Um, uh, but I'm not quite sure about the large scale incinerators, but I can certainly speak to the small scale incinerators because I've done some research about that. So there was a University of Texas study that looked at small scale incinerators that incinerate between 1 to 5-6 tons of waste per day. And on average, to dispose of 5 tons of waste, they would use something like 800 gallons of diesel per day to dispose of 5 tons of waste, which is a huge amount of fossil fuels. And our invention basically uses zero fuel. It doesn't use any fossil fuels at all. So 800 gallons of diesel or zero, right? Your operating costs are much lower,
That,
hugely lower.
yeah, wow. So how does the plasma, without getting too technical, because this my audience is definitely not a technical audience, how does this plasma thing heat up and
Yep.
produce enough temperature and pressure to get rid of the waste?
So our secret invention is an ionizer, and what we do is we basically take atmospheric air, just normal air from the environment. We suck it through. We have some pumps and blowers, and we suck it from the air and push it into the furnace, and we push it through our ionizer. And what the ionizer does is that it decouples the oxygen molecules. So oxygen is O2. It forms a molecule, and by breaking apart that molecule, we have atomic oxygen. I love the term atomic oxygen. That's our superpower, right? It sounds like a Marvel Comics superpower. So that atomic oxygen, that's what the atomic oxygen and the free electrons that are circulating. That's what creates the immense energy. So we see temperatures in the furnace of up to like between 1,200 to 2,000 Fahrenheit, and that burns off a lot of the furans and the dioxins and the toxic fumes that come off when you burn garbage because of that intense high heat. And because of that high heat, we have about 1% ash. Whatever waste we put in is reduced to about 1% ash. So we have a very complete combustion process. A typical incinerator would produce up to like 10% ash. So that their process isn't such a complete combustion process. And the cool thing about atomic oxygen, apart from producing this high intense heat, is that the oxygen molecule isn't available for the pollutants to form. So if you go to our website and there's a video there, there's this picture of Tammy one evening and she's turning on the ion generator and there's smoke coming out from the furnace. And literally when she turns on the ionizer, that smoke just goes away. It just doesn't form. And because we don't have that oxygen molecule to form the pollutants, so, for example, let's say in United States the limit on incinerators for furans and dioxins. So, furans and dioxins are the part of the chemicals that are potentially cancer causing, right? So, the limit on that is 33 parts, 33 nano something or other, 33 parts per cubic meter, and our machine only produces 0.1 nanograms. So it's 300 times more efficient of getting rid of that furans and dioxins, um, because of that atomic oxygen.
Interesting. And sort of the main difference is that those cancer causing elements need to bind to
Yes,
oxygen essentially to get
yes,
out and
O2.
to
Yeah,
spread out into the world. Wow.
yes,
And the
yes.
ash part, like going back to a regular incinerator, what happens to that ash in the current supply chain?
Actually, ash from incinerators are actually quite highly valued because they actually make bricks from it. They can make bricks or pavers, you can actually make bricks using 80% less concrete. And actually, concrete, cement and sand are actually cement is a very carbon intensive material, right? That it's
Yeah.
produced from limestone. It's very, very carbon intensive. So if you can make bricks using 80% less concrete, that's a winner, I think. And you're
Okay.
making bricks from trash.
And that's what, so is that the primary use of ash from incinerators today?
I'm not sure about the general incinerators, but there's
Yeah.
certainly, in our the Phoenix, the machine that we've invented, we call it the Phoenix. That's what we're advocating, that people take that ash and they actually upcycle it into bricks.
Into brick. Okay. And so the ash itself, like from your machine, is it safe enough where you can just touch it with like your hand, or do you need special equipment to deal with that kind of stuff?
Yeah, so we've done a T-clip analysis of it and looked at the chemical content. So it has no heavy metals. So it's actually safe for use. It can actually be put into soil, right? It passed the T-clip analysis. It's not considered hazardous waste. So I can't, certainly from our Phoenix, we've done the analysis of it. We obviously haven't done the analysis of every single possible types of waste that can go in. But from normal household waste, we've done a couple of different sampling of the different of the ash, and it passes the toxicity tests.
Okay, great. And could you use the Phoenix to, let's take plastic. What happens if you put plastic in the Phoenix?
It goes away, right?
Okay.
It basically gets converted into that 1% ash. I've
Okay.
put in a whole TV set, for example. I put in a whole TV set, a printer, some old electronics that we have. And basically what happens is that the plastic all disappears, and the steel circuit board, I can retrieve that for recycling.
Okay. So at the bottom of the tank, any of the metal stuff will still be there.
Exactly.
That's really cool. And you were mentioning earlier before we hit the record button that there's some like pretty high powered people interested in your technology, like the American Department of Defense. What can you tell me about that conversation?